This is video number 2 on chapter 28, slope of the tangent line. And I'm going to do the first two parts of example 237. I'm going to do this differently than what's in the notes. So in the notes, the derivative is calculated using the definition of derivative, and there's nothing wrong with doing that. And the reason that the solutions worked out that way is I have sometimes done this chapter before I did the techniques of differentiation chapter. In other words, we didn't have the methods of differentiation for the algebraic functions that we now have. But now that we have them, we'll use them. And so we were given the function x squared minus 3, and we want to find the equation of the tangent line at the point where x is negative 2. So what we learned in the last video is a derivative gives us a slope of the tangent line. So we calculate the derivative. It's simply 2x. And now, how do we find the equation of a line? We need an x-coordinate, a y-coordinate, and a slope. We're given the x-coordinate. How do we find the y-coordinate? We substitute the x-coordinate into the function. So we evaluate the function at negative 2, and we have 1. How do we find the slope? Well, we evaluate the derivative at the x-coordinate. So we substitute negative 2 for x in the derivative. This gives us the slope. So the derivative of f evaluated at negative 2 is negative 4. So now we have an x-coordinate, a y-coordinate, and a slope. So we'll find the equation of the line. We have y minus the y-coordinate is equal to the slope multiplied by x minus the x-coordinate. So here we have x minus negative 2, which is the same as x plus 2. Find the derivative, substitute x into the derivative, that gives us the slope. Substituting into the function gives us the y-coordinate. It always has. So, but now that we've learned that the slope, that the derivative of the tangent line is slope, sometimes students confuse these two processes right here. For part B, we're given the function k of x is 1 divided by x squared. We rewrite k of x as x to the negative 2 so we can use the power rule. So we calculate the derivative, we just multiply by the exponent, decrease the exponent by 1, that's the power rule. Rewrite this as a fraction, that's optional, but I think it makes it easier to work with. So we wanted the equation of a line. Again, we need an x-coordinate, a y-coordinate, and a slope. We're given an x-coordinate. It's 4. To find the y-coordinate, we substitute 4 for x into the function. So k of 4 is 1/16. To find the slope, we substitute 4 into the derivative of the function. So k prime of 4 is negative 1/32. Now we write the equation of the line. Y minus the y-coordinate is equal to the slope multiplied by x minus the x-coordinate.